All right, we'll go ahead and get started. Once again, welcome to PaleoPerks. Thank you all for joining us today. We are an early career researcher seminar series, and today we are really excited to welcome Letícia Rezende from the Federal University of Santa Maria, Brazil. She's going to be presenting a talk titled A Biomechanical Tale, Reconstructing the Largest Predator of Brazilian Middle Triassic. Before we get started, a little bit of housekeeping for you. First, we have this welcome and announcements. This will just take a few moments. Then Letícia will take over with her talk, which will last about 30 minutes. We'll have about 10 minutes for Q&A. If at any point during the talk you have a question, you can go ahead and send that directly in the chat to the questions at PaleoPerks host, which today is Salman. And then we will have a tea time where you'll be able to chat more in an informal setting with Letícia. Just a bit of housekeeping on our end. We always want to remind you that we value the participation of all folks interested in the paleosciences, and we ask that you remember to abide by our code of conduct during today's seminar. You should all be muted. Please remain muted for the duration of the talk. We can unmute during tea time if you'd like to stick around. As I mentioned, you can ask questions by chatting to the questions at PaleoPerks host, or at the end when we're doing the Q&A, you can use the raise hand function. And if you're having any technical difficulties, that can also go to the questions at PaleoPerks host. There should automatically be captions showing up for you. If you're not seeing them, you can use the CC button to show or hide them. And then we're going to drop a couple of links in the chat. So we always welcome nominations of outstanding early career researchers who might like to share their research on PaleoPerks. And we also have a weekly feedback form for demographic information, which is always anonymous, optional, but encouraged. We also want to give a quick reminder that many countries are in the process of, or many municipalities are in the process of shifting to or from daylight savings at the moment. So please keep a close eye on emails if you are wanting to join future seminars, because times will be shifting. Generally, we follow UK daylight savings for when we switch times, but the time in the end should end up being the same for most people. But recommend keeping an eye on emails and using our calendar function, which is available on our website if you have any questions there. So now I would love to introduce you all to Letícia Rezende. She did her bachelor's in biological sciences at the Federal University of Santa Maria, also her master's there, and is now a PhD student. And with that, I will pass it over to Letícia, and we're excited for your talk.
Thank you. I'm sorry for my voice. I'm recovering from a cold that I got during the weekend. So if it is a little difficult to understand, you can always question me later. And I'm going to present to you a little bit of what I'm doing during my PhD, my doctorate, as we speak here in Brazil. To reinforce basically what Win already said, but during my graduation, undergraduation, I already started working with paleontology, and during that time, I studied Prasuchus canicensis, which is one of the largest animals that we have here. And during my master's, I managed to at least publish the studies and the researches that I did during my undergrad time. I also started to describe an indeterminate archosauriform, but is still a work in progress. And for my doctorate, I decided to change a little bit, getting out of the taphonomic and anatomy description, and start working with biomechanics. So to be able to do that, I did an internship at Harvard, the Museum of Comparative Zoology, under the tutelage of Stephanie Pierce and Peter Bishop. So they could teach me the very basics of how to start doing the whole biomechanical process to deeply understand the animal that I love so much. So to put everyone around the same page, the Triassic period, it is the first period of the Mesozoic era. It is between two of the major mass extinctions that we have. So it is a moment in life very peculiar because many of the living fauna and flora died with the biggest extinction that happened at the end of the Permian. And a lot of new different lineages appeared, including the now dominant um, lineages that we have, like mammals, dinosaurs with the birds, and turtles, and so on. And also during that time, the land masses were distributed as a supercontinent. So we had this very large desert in the middle. But where I'm going to focus is at the south of this big desert. So we had a kind of a biome, savanna biome around here. So we have a little bit more of a diversity. And to in the whole Brazil, basically, the Triassic that we have that had fossils is concentrated at the Rio Grande do Sul state, which is the southernmost state of Brazil, and basically concentrated in this very thin red line here. So this is the Santa Maria Formation and also include the Caturita Formation. So most of our fossils from Triassic, Middle Triassic, Upper Triassic comes from this very small thin line that represents our biodiversity. It does correlate with Argentina. So the Triassic that we do have at Argentina, it's continuous and correlation with that, and also a little bit in Africa. Um, our Triassic presents as those beautiful reddish, orangish kind of sediment and dirt, and it appears usually by open roads and the construction of those artificial lakes. So we usually do those field trips around some like artificial lake, which makes everything very muddy and dirty, but it's very useful also to work. And specifically talking about the Pseudotsuchia lineage that I focus on, it is the part of the archosaurs, the crown group that keeps the birds, extant birds, and extant crocodiles. But the Ornithogidae side of the lineage have the dinosaurs and the most famous section of the tree. But the Pseudotsuchia lineage is the one that keeps the crocodiles, then the alligators and gharials. So we have this part with very strict morphotype alive extent now. But during the Triassic specifically, they had quite a bit of diversity into morphotypes and tested everything a little bit too. So just to give an idea, we had like small bipedal ones like Shuposaurus. We had even edentula-like with a beak like Aphasia. We have those that remained pelycosaurs with those sailback also appearing. Large top predators, small predators. We had those very armored-like that resemble like Ankylosaurus, but a lot older, but very with this very thick osteoderm-like carapace around it. But specifically talking about Pristisuchus, which is my personal love, it is inside loricate, inside Pseudotsuchia, it is a loricate, so it is closer to crocodilomorphs, but not properly. It lived during the Middle Triassic, so it was not as close to any of the big extinctions that we had. an apex predator with around 7 meters anteroposterior length, so quite large, and well distributed in that thin section of Triassic sediment that we have along our state here at Brazil. And we have some amazing fossils, very well preserved and very complete too. So those were already prepared and described, and we have like almost a complete skeleton just from we just don't have the tail basically, but everything else is there. So to tell a little bit of what I wanted to do in my doctorate project was to explore the posture and the stances of Protosteuchus. But why? As I said, Pseudotsuchia had quite a variety of mortar types. And one of the things that shift a lot is that posture of bipedal and quadrupedal. And Protosteuchus is there close to Postosuchus in a part of phylogeny and not so easy to understand. So we do have Poposaurus and other Poposauroids that are very bipedal or specifically bipedal, and even some loricate that are bipedal too. And Prestosuchus have a not specific position and not so easy to ascertain if it was like totally quadrupedal or if it could like at least had a bipedal kind of possibility to like use it sometimes. And also the loricate in genera could also achieve an erect posture different from what we know nowadays for an erect posture, like dinosaurs and mammals. So for what we know, usually the femur had a modification, having the head of the femur bend inwards to better allocate in the pelvic girdle. And for the Rauisuchians or loricates, what we have is actually the pelvic girdle bending outwards to better accommodate the femur. So they both achieve the same position in an erect stance, so keeping the femur vertical to the ground, but with different ways of achieving it instead of the sprawling position that we have with the femur more horizontally positioned. Um, However, the extant Pseudotsuchians did return to a kind of sprawling position that we have with crocodiles, for example, but we can see through the fossil lineage this shift happening. But my main question was like, yeah, I want to see that, but how do I do? I suppose that I will need a leg. I have a leg, all right. And can I put it to walk? Maybe. Um, how far do I need to go? How much do I need to go to actually make it walk? A lot. Um, so I started like from the very beginning preparing fossils, but I could not use the fossils that I was preparing because it's a very large animal and with a lot of material, and I need a complete model of the whole skeleton, so I won't have time to prepare all that. So I grabbed another material that was already studied and prepared and isolated to manage to digitalize it. So we used laser scanners to make 3D models that we could input into softwares to start doing some of the approaches that we need to estimate and to try to work with the biomechanics on top of it. So, okay, we have the elements of the bones, and now we need to put it all together. How we do have complete specimens, but not one complete and beautiful, perfect. So we needed to input with some other specimens to complete. So the different colors show different specimens and materials that I needed to utilize so I could have a complete skeleton. But okay, I managed to put everything together in a possible position for to actually understand Protostachys. Um, and then we could using that model, that articulated skeleton, we could identify some ranges of motion, so limits of how much a limb could, how the articulations could bend, so how much it could flex or extend, um, understanding the degrees of freedom that each articulation have. So like the hips have more movement possible than the knee, for example. Um, so, okay, and now we can actually get to the first thing related to going to a biomechanical approach. So, to estimate the body mass, that is one of the most important parameters that we have to work with anything, because the weight have implications in all aspects of life of an animal. We did the hoop-based method because it can take in consideration more than other volumetric matter methods, and especially more better than other extent scaling methods, especially because we can not only work with simple reconstruction, like make hoops following the skeleton, we can also consider it as being contracted, so like a smaller animal or a thinner animal, and expanding it also so we can have a thicker animal. So basically, we could also mimic starving kind of animal of the same of a certain size and the same size, but with a lot of food available for it to eat. So we can estimate and have those differences between the same model, so we can achieve more possibilities while working with it. Um, okay, we have the body, but we need now the muscles, and we only have bones. So we try to look at those bones and try to understand and see muscle scars. So where muscles have origins and insertions, it usually keeps some ridges or rugosities um, at the surface of the bones. So we can use that to identify, especially using a methodology called extent phylogenetic bracket. So basically working with a phylogenetical method, but just focusing on musculature. So um, you use the extant living animals to try to retrace how muscles could be, where they could be, because we only have the scars of the muscles and not the name of it. So we need to make it easier to understand where each muscle would actually attach. And not only the attachment is important, as also the paths, sorry, that each muscle crossed across the leg. So which ones are more internal and which ones are external. So we could actually achieve morphology that would like function. So when moving this leg, it wouldn't have muscles like crossing each other or passing across each other. They need to be in a certain position where they can move together and not intertwine. So, okay, made the leg, put all the muscles there as better as I could. Um, we can see like this is with the skeleton showing, and this is just the muscle path. So each muscle connected between each other. Um, and I need to know what how how strong those muscles are, because well, if my goal is to put it to walk, I need to have how strong they are so to manage to actually walk. So another thing is to estimate muscle properties. Um, we use the muscle properties to identify and to estimate with equations how strong a muscle could be. So, and living animals, it's a lot easier because you can dissect them and measure. So, with using parameters like length, mass of the belly of the muscle, the pennation angle, and informations like that, we can estimate the maximum force that a certain muscle could achieve. So, with that, using many dissections and understanding of extant animals nowadays, we can have a huge database where we can use it to actually put it into equation that we can input the information that we actually have in our models. So in our case, we had the body mass of the animal, like the complete body mass, and how much how the length of each muscle too. So we could use those data to actually try to estimate the maximum forces of each muscle. So I did a couple of different methodologies to try to see how each of them would behave with the model that we've made. And also, okay, I have a skeleton, I have muscles. Um, I want to see if it could stay in a bipedal stance or if it, and also if it use it as an erect or a sprawling stance. So my first tests, that is what I have right now still, um, was trying doing extended knee positions and flexed knee positions to try to test a little bit of crouched um, stance that it could achieve, and also having erect femurs, so more vertical to the ground, and more sprawling femurs, so it would be more horizontally related to the ground. And we did a static optimization simulation where I inputted all the information that I've got until now. So the weight of the whole animal, the forces that each muscles could achieve, and how it would distribute the weight not only of the whole animal as also with each part of the animal, so how much the head would weigh and those things. And then we apply gravity and like actual physics on top of it and put it in simulation. We use OpenSim to run all the simulations. And it we see that with the muscle forces that we got from a certain approach, if it could actually stay only in this hind limbs, or if it would collapse because the muscles wouldn't be strong enough to keep the animal in that position. So in one of the methodologies that I've tried, we actually got some different results. So we can see that erect postures actually are able to stabilize themselves. We can see the steroid ones are the ones that actually functioned and managed to keep balance. So we can see that the erect posture, almost all of them, just one of the positions couldn't sustain its own body mass onto its hind limbs. But with this sprawling stance, with the femur being more horizontal, it couldn't have enough forces, enough strength to actually keep the body over the ground, so to actually maintain this position. And also we can see that flexed knees have had a better resolution because it resembles how big quadrupedal animals nowadays have a posture when they decided to go on just its hind limbs. So like we have elephants that do get only on its hind limbs to get to higher trees or something like that. So they usually put this crouched stance where they flex the knee in a certain position that makes the body, the force muscle distribution for distributing the forces can achieve a better, um, a more stable and comfortable position, I would say. So I think when we crouch, when we like do exercises and we crouch in the ground, it have some positions that are easier to be achieved and easier to stay for a longer time than another. So especially if you open your legs too much and you're not made to open your legs so much. So um, some of them are comfortable, some are not. So um, kind of this idea. But of course, this is one of the results. I had others that none could sustain and others that all could sustain. So I need to try um, more about that and to play a bit more and explore deeper those details, those biomechanical aspects. So actually, what I have is very little. Um, I've I've learned a lot, and like what I've become with learning with the biomechanics is like it opens your mind in different ways that you started to have a lot more questions and you wanted to explore a lot more. So in this line of work specifically, I still have a lot to do, but actually I started like five other things and tried to explore a lot of other things because you start to see many potential works that you can do also. So it is definitely a path of work that I will continue to work on. But I wanted to show a little bit of my love about it to you all. But not to finish with just what I do. I wanted to show to you all also a little bit of what we do at Kappa, which is a center, a paleontological supports research center in the southern Brazil, because we have quite an impact, actually. So we do have a specific building just to paleontology. So it is a center that we are not at the university. We are very far away. Hour driving my car. But we are actually in the middle of a lot of outcrops, a lot of fossiliferous Triassic outcrops. So what we have is actually a lot of work to do and a lot of things to explore around here. And we are a quite young center of research because we have like around 10 years or so uh, actually exploring what we have around here in our region. And we work in all of the steps. So from prospection, going to the outcrops and start to searching about fossils and do when we find something, we do the collection, we take them to our center. We ourselves do the preparation. So we have all the mechanical like micro jacks and those materials to and scallops to prepare everything. We also have surface scanners, so we can digitalize things, and we do CT scans when needed. And also, we have workstations to be able to segment to those materials, so we can have those all the information that the CT scan can provide us. We obviously describe the materials that we find and prepare and publish it. So we have this specific special issue from anatomical record was um, edited by my advisor, Flávio Preto, and other colleagues, and was the largest issue of anatomical record so far. So we, as a total of talking about Triassic, we have a lot of connections and a lot of impact also because many of those articles were from Kappa or with researchers from Kappa. And we also have a little bit more. We do some replicas. We even paint them, uh, do with 3D printing too. So we can also manage an exposition. So we have a little bit of our museum with some of the materials that we find here, some replicas and some are real fossils, and we share with all the community that we have because Kappa managed to talk directly with people around here. So we have visiting from the owners of the outcrops, like the farm owners, to come to visit to see the materials that were found at their house, their home. So we also have a lot of appeal to children. So we do some holiday events to call for them, and it's a very complete center because we act in so many aspects of paleontology. I think that almost all of them, for vertebrate at least. Um, but yeah, that was it. I'm sorry for being nervous. But I wanted to basically show to you guys what a little bit of what I do and what we have here in southern Brazil. So thank you for your attention.
That's fantastic. Thank you so much. I learned a lot. That is an incredible amount of work and data that you've put together um, on Pseudotsuchia. It looks like you've learned a lot about it, contributed a lot to our understanding. And thank you for sharing about the work that you're doing at your institute as well. That's always really, really helpful and interesting to hear. Um, so now's a great time for anybody to send their questions either in the chat or to the questions that PaleoPerks host if you'd like to remain anonymous. It looks like we have a couple of anonymous questions to start us off with. So first one is why is Pseudotsuchia preservation so good in Brazil?
Um, Mostly, I think I'm not very good at taphonomy, but we have a lot of those food floodplains. So most of what we have preserved are those sections of um, rivers that have floodings and deposit a lot of mud on the ground. So we have many layers preserved. Um, I also can say that we always think that the neighbors is prettier or something like that because sometimes we have fossils and we think like they're awful or badly preserved. But uh, we go to other places and see like amazing fossils and like actually they think that our fossils are amazing. So I think that everyone have good can have good materials. We just need to uh, appreciate our own fossils a little bit more. But here in Brazil, we have those footplanes that actually do quick um, burrowing, not burrowing, but they deposit very quickly. So the fossils that we have are usually very young, like recently dead materials, so it can preserve more information when they are uh, over with they put the dirt over it. So yeah, I'm not good with autonomy, but I know that is a very good point to that.
No, that's perfect. That totally makes sense. Looks like we have another anonymous question that I'll send in the chat. So somebody wants to know how accurate are these models to estimate muscle strength and structure? And I think as a follow-up question, how do they decide the muscle structure for a very newly discovered species?
Well, how accurate? They're always model, so we don't have the living animal to actually say that it is 100% sure. Uh, but we try our best basically to ascertain it. And the muscle strains, it is very complicated, and it is a point that I myself get really insecure about it because Prasusuchus, at least, is a large pseudosuchia that was completely terrestrial. So we don't have nothing now extant living that lives in the same conditions in the same way with the same muscles. So when we get pseudosuchia database, extant pseudosuchia database from crocodiles, for example, they do have very weak legs because they are aquatic. So they don't need to run. They don't need to get a prey by running. They have very strong tails, but they don't need strong limbs. So when using them, it gets very weak. And if we decide to use, okay, all closer related, so we use all Archosaur database, and we get crocodiles and birds that also don't run. So uh, it is very complicated to get because we can have all of those different, um, very different lifestyle from what we have now. And we have some other approaches that do consider more broad perspective. So it doesn't actually follow like for a specific of each muscle strength. It does for a general idea of how the whole limb would work or sections of the limb would work. So it doesn't get very accurate, but it does manage to uh, put the model in a certain useful position so it can like really stand and really balance itself. So um, I'm not the the very specialist to say how accurate they are, but I know they are very like hard to actually grasp the idea of it. But I think that as long as we have accessible data and like everyone can try to replicate and understand the methodology and what was done, I think that we can always help and share. So I try to use the most variety of approaches that I've seen trying to reconstruct muscle strengths for pseudosuchians, like extinct pseudosuchians. Um, so uh, that's complicated. You have to like decide for your approach, basically. And how to decide muscle structure for newly discovered species, you have to hope to see the muscle scars and the bones. Have a very good preparation to get the details and get a good preservation to be able to see those scars and try the EPD. I didn't explain it very well. I haven't done it because we have previous works that did the reconstructions of the muscles and Prasusuchus, so I could at least just get this information ready. But it is not complicated and basically just do a data matrix with like which muscles are present and where they attach to see which one fit better, which muscles fit better in your model, in your new material. So you can, it's basically test. And we have levels of inferences, like we have muscles that we are certain that they are there because they preserve for like the long of the lineage. They are very stable, and we have weak levels of inferences in some muscles that they are vary a lot during all lineages. So all of those details need to be very well explained when you are reconstructing muscle morphology.
Yeah, it makes sense. Looks like you were very meticulous about trying a lot of different models, and I imagine that's the way
Yeah.
you have to do it unless we're in a Jurassic Park kind of situation.
Yeah,
Uh,
like you can decide and just go with the one goal, but like I like to explore, which
yeah.
makes you get lost a little bit in the idea because you do so much that later is hard to focus on. But that's the general aspect.
No, it makes it a strong argument. It makes a lot of sense. Okay, it looks like we have just one more question unless we get any more in the chat shortly. But for now, we will go with this. If you could expand, looks like they want you to expand more on next steps. What's next in your work?
Yeah, basically I want to learn more, basically. Has I've Most of what I did was during the 6 months that I've stayed at Harvard University, that I was being guided directly. And once I get back to Brazil, I just like reorganize the data and try to like starting to focusing some articles already to manage the to publish. So what do I need to do now is to focus. Because as I said, biomechanics is amazing because you start to see a little bit too much of things. So I got distracted a little bit of what I was doing with other things. But to the this limbo reconstruction, that this specifically with the Pristisuchus posture reconstruction, um, I want to test some other positions and some other possibilities with the actually go with more information about the position of the femur with the pelvic girdle to actually have a better understanding of how how it would affect having a more sprawling position to a more erect and those kind of ideas. I would love to work with finite elements, but I think it is a whole other thing that would need another doctorate to do. So maybe in the postdoc in the future. But I want to explore a little bit more of that idea and try to uh, pinpoint a little better the details about having a bipedal or a semi-bipedal stance and this erect posture.
Sounds like you have a lot of great proposals for a postdoc. That's what it sounds like to me. All right, I think we'll wrap up the Q&A there, and say thank you again for such a fantastic talk. Um, for all of our participants, there will be a weekly feedback form dropped in the chat in a moment. Again, we just like to learn about who is attending each seminar. Next week, we're going to have a slightly different talk than we usually do. It's going to be Joanna Tyndall from Plus One, who's going to be giving us some tips and information about publishing for early career researchers. And so now we're going to transition to tea time with Letícia. So if you'd like to stick around, we'll take about a 2-minute break if you need to turn off your camera, grab some water or anything. And then Letícia has agreed to stay around to chat with anybody who has more questions. So we'll do that now.